Hello, good day to you all, and welcome back to Elega Research Institute. Today, we'll be talking on epidemiology and public health. But we want to pick one subject that helps in measuring the relationship between two numeric variables. So, today's topic under epidemiology, we'll be talking on what mainly about statistics, and under the biostatistics, we'll be dealing with what correlation and regression analysis. So, correlation and regression analysis or a model. So, firstly, we have to know that this correlation and regression analysis helps us in what in finding the strength between two numeric value, in which the numeric value can either be what, namely as x and y. So we are talking about the correlations and what and the regression. These both to are being used to what to evaluate two numeric values to check their strength and what and their relationship. So first, let's go with correlation. So what we mean by correlation is just a mathematical statistics which help us to know the strength between two variables, and this variable has been named as what as x and y. So if you name it as what as x and y, in which our x be independent variables and our y will be what dependent variables. This is very good in what in biostatistical analysis, which help us to know the relationship between two variables. Like example, if you have nutrient given with the growth of a fish, so it means we are making a correlation, a relationship between two variables, in which the nutrient taken in by the fish and also the growth of the fish. So for us to know that, we have to do what correlation analysis, in which we find our x should be the nutrient, which is the independent variables, then our y is going to be the growth of the fish. So for but the regression analysis measures the strength between two variables along the straight line. And we have to know very important difference between correlation and regression is that correlation measures the value in minus to plus one, just to measure the strength. But the regression analysis is being equate, like the value shows in equation, in straight line equation. So for us to calculate the word correlation, let's get it to be short. So for us to calculate the correlations, we have to use a formulas which we call it as a constant as R. This R is being denoted by a mathematician called a Pearson. We call it K Pearson. He said our R, which is the coefficient of the correlation, will be equal to summation of x minus x bar, then open the bracket y minus y bar, all divided by square root of x minus x bar square, then y minus y bar square. So this is the formula that we are going to use for what? To calculate our correlations. But mainly in highly imputed way. There is no any high statistical research that they still use this formula. It's mainly used in what? In computer modulations. But for us to understand, we have to know mainly why do we calculate our correlation? We want to know the strength of relationship between two variables. Like example, since we are dealing with biostatistics, we have to talk in a relationship to medical perspective, like taking in of a dosage and getting better of the patient, like how patient is responding to a dosage given to the patient. So we are making a relationship between the drug taking and the betterment improvement in health of the patients. So now this is the formula that we're going to use, but don't be confused. A lot of students have another formula which it shows like this, but all of them are the same thing. You just make an evaluation of this first formula. This formula can also be rewrite as this. It can also be equal to our R is equal to summation of xy minus summation of x dot summation of y, all divided by n, then divided by square root of summation of x square minus summation of open bracket x square, all in bracket, divided by n, then open another bracket, summation of y square minus summation of y square divided by what? N. As we can see, some students said this is the formula they have, some others said this is the formula. This formula and this formula, they are all the same thing. It just makes a simplicity of this one to give us this. As this formula can also be expanded further to give us this, in which our R can also be equal to, we can find the square root of this one, which can give us our n summation of xy minus summation of x dot summation of y, all divided by a square root of what? Of n summation of what? Of x square minus summation of x square, then open another bracket, n summation of y square minus summation of what? Of y square. This formula, and this formula, they are all the same thing. Just make a simplicity of this one to give us this, and this one to also give us this. So either of the formula, whether you use this one, you use this one, or use this one, they are all the same thing. And if you need, we are going to do a videos in mathematical proving of this, but let's make it shorten. So this is our formula for correlation coefficients. So let's make an example. As we have already know our formula, let's proceed. Okay, like example, we have been given a two variables, which is equal to what? Our x and what? And our y. As I've said earlier, s is what? Is the independent variable, and our y is a dependent variable. Assuming we want to make an what? A correlation between weight gain and the food taken. So our x is going to be dependent, which is got our food taking, the nutrients. Then the y should be our weight. So it means that we want to make a relationship between the what we take in and how far we get the weight. So if assuming we have a correlations that this one is 2, this one is 5, this one is 4, this one is 6, this one is 6, and maybe this one is 9. So from this kind of relationship, we have to understand our correlation coefficients should never exceed plus 1 and should never be what? Less than minus 1. So our correlation value can never exceed. Is either is what? Is plus 1, minus 1, or what? Or 0. If our correlation value is plus 1, it shows it's what? It's a linear correlation. So this one tells us that they have a very strong relationship between the two variables. So if you have minus 1, we call it inverse, because there is no strong relationship between them. But that doesn't mean that they don't have any relationship. But if our correlation value is 0, it shows that there is no relationship between the two variables. And if you want to draw the word, the scatter diagram is going to look like this. For a linear regression, we'll be having a straight line like this. So if you have a what? A inverse correlations, it's going to be like this, the opposite side way. And if you have 0, it means there's no correlation between them. The scatter diagram is going to look like this, as we can see. And in a simple word, we can say linear regression is what? When x is increasing, our y increases. It means when the variable, independent variable, is increasing, our dependent variable will also be increasing. But when it is minus 1, it shows that when x is decreasing, this one is increasing, or when this one is decreasing, this one is increasing. Then for the 0, they have no correlation between each other. So let's just solve the first question. Assume we find the correlation value for what? For this data. Based on the scatter diagram, if you draw it, you can see that it's going to give us what? A straight line. Like assume this one is our y. Our y will be represented in what? In vertical axis. Then our x will be represented in what? In horizontal axis. So if you have 2, 4, 6, then this one is 2, 4, 6, 8, and 10. So when we have 2, this one is 5. 2, 5 is going to be around here. So when we have 4, this one is 6. 4, 6 is going to be around here. So when we have 6, this one is 9. 6. No, when we have, okay, when we have 2, this one is 5. 2, 5 is around here. This is 5. When we have 4, this one is 6. 4, 6 is around here. Then when we have 6, this one is 9. 6, 9, 9. This is around here. As you can see, if you draw this thing, it's a straight line. It means that the value is being distributed along the what? Along the straight line axis. So we can make an inference that this is supposed to be what? A positive correlation, which can be a what? A value which is going to be greater than what? 0. So let's do the mathematical calculation for it. So for this, since we have already know that, let's do the calculation for this. Let me write the formula at the top, the formula that we'll be using, so that we will not forget. Our R is equal to summation of xy minus summation of x dot summation of y divided by n, or divided by square root of summation of x square minus summation of open bracket x close the bracket of x square minus n, then open the bracket of summation of y square minus summation of y square divided by n. So this is the formula that we'll be using. So when we have to analyze this thing, we are going to draw another table to make it very easy for us. So if you draw another table like this, if you draw another table like this one will be our value for x, this one will be our value for y, this one will be our value for x mean, y mean, then this one is going to be our value for x, y, this one is going to be our value for s square, y square. I think that's all that is needed. Okay, now our x is what? Is 2, this one is 5, this one is 4, 6, this one is 6, and this one is 9. What is the mean for this value? Our mean is what? Is 4. You simply take what is in between them, or we make a summation of it. You can say summation of what? Of x divided by n. That's what I mean. This is going to be 2 plus 4, it give us 6. 6 plus 6, it give us 12. 12 divided by 3, it give us 4. So the same thing for this. Our mean is what? Is 6. And you can plus them together. 5 plus 6 give us what? 11. 11 plus 9 give us 20. Then 11 plus 9, 20. Then 20 divided by 6 is what? 5 divided by 6, 5 plus 6 it give us 11. Then 11 plus 20 divided by 3. It should give us 6 points. I think 6.3, 6, 12, 18. It's going to be around 6.26 by. Okay. So these are mean for this one. Okay, then our xy is going to be 2 multiplied by 5 is what? Give us 10. Then 4 multiplied by 6, it give us what? 24. And 6 multiplied by 9 give us what? 6 multiplied by 9. So 54. So for our x square, 2 multiplied by 2 give us 4. 4 multiplied by 4 give us 16. Then 6 multiplied by 6 give us, I think, 32, right? 36. 6 multiplied by 6, 36. So for our y, 5 times 5 will give us 25. 6 times 6 give us 36. Then 9 multiplied by 9 give us 81. So these are the value that we need here. So now let's substitute all these value in this what? In this formula. So you can see it's going to be our summation of xy. So now firstly, let's add all of them together. Summation of what? Of x is equal to 4 plus 2 give us 6. 6 plus 6 give us 12. So summation of y is equal to 6 plus 5 give us 11. 11 plus 9, 20. So summation, this one, x, y bar. Then summation of what? Of xy. Then 54 plus 24 give us what? 78. It give us 88. Right? Then summation of what? Of s square is equal to 16 plus 4 give us 20. It give us 56. And the summation of y square is equal to what? 25 plus 36, it give us what? 61. 61 plus 81, it give us what? 142. Is it correct? 142. So let's go. So now let's inside the formula here. Summation of what? Of xy. Where's our summation of xy? Summation of xy. Summation of xy is equal to 88. It's going to be 88 minus. What is summation of x? Summation of x is 12. 12 dot. What's our summation for y? Summation for y is 20. Then divided by, what's our n? N means total number of the population, in which our n is what? Is 3. Then all divided. So from there we have square root of. So we are going to have summation of s square. Where's our summation of s square? It's going to be 56 minus summation of what? Of x, then square it, which is going to be our 12 raised to power 2 all over 3. Then summation of what? Of y square is going to be 142. Is it 142 minus our y square, so 20 square divided by n. As you can see, summation of s square, this is summation of s square, 56. Summation of what? Of x. Summation of x is what? Is 12. This is 12 raised to power 2 Then summation of y square is what? 142. This 142. Then so summation of y is what? Is 20. This is 20. Then divided by what? Our 3. So continuation, our half is going to give us 88 minus, this one is 12 times 20 divided by 3. Give us what? Eh? 12 times 20, then divided by 3 give us 80. Divided by, we are going to have square root of 56 minus 12 times 12 is what? Then 144 divided by 3, 48. Then open the bracket, 142 minus 20 multiplied by 20 is 400, right? Then 400 divided by 3, I think is 133.3, right? So let's do the continuation here. As you can see, then our R is going to give us 88 minus 80 is going to give us 8 divided by square root of 56 minus 48, it gives us 8. Then 142 minus 133.3 is what? 133.3. It gives us 8.7. Then 8.7 multiplied by 8.7. 8 multiplied by 8.7. Then our R is going to be 8 divided by 69.6. Then square root of 69.6. Square root of 69.6. So our R is going to be 8 divided by square root of 69.6. 8.342. Then 8 divided by 8.342 is going to give us what? 1 point what? 8 divided by 8.342. 0.95. Is 0.95? Okay. Yoruba. As we can see, the correlation coefficients here is what? Is 0.95. So that's our correlation value. It shows that they are directly correlated. As you can see, it's positive. It's 0.95. It shows that they have a strong correlation between each other. As you can see, we have already drew the scatter diagram, and shows that the variables are distributed around the what? Straight line axis. So that's why we get this kind of what? Answers. So that's all for what? Correlation. Let's move to what? Regression analysis. So in regression models, it's quite different. I've already said it's being represented in form of what? Of linear equations. So apart from it's being represented in linear equations, then they measure the what? The relationship between two variables, the strength between two variables, while the correlation tells us how strong they are to each other. So let's get started. Let me leave the formula for correlation of the, this one is, so for the regression analysis, regression analysis, I've already said it measures the what? The relationship, the strength of relationship between two variables, which is what? X and Y. So for our regression, we'll be talking about straight line. I've already said the line, when we are talking about the what? The slope and gradient of what? Of straight line graph, we are going to have our y, which is equal to what? A plus what? Of bx. So that's what we'll be using here, because we are measuring the strength of what? Of two variables along the what? Straight line axis. So our regression, we'll be measuring the what? In which our y is our what? Our dependent variable, which is what? This is the y, this is our x. Then our a is going to be the line that crosses the y-axis. So the line that break the y-axis, we call it what? Our a. Then our b will be our slope. So it's our slope. Then our x will be our dependent variable. So for us to get a regression analysis, we firstly, it's very necessary for us to So for us to get a regression analysis, we have to know all these things. So let's continue. If our y is equal to a, we'll be measuring the what? The b, in which we'll be name it like this, our b nil like this. It means we firstly calculate the slope of what? Of the data given. So let's use the formula, the same thing that was given. So we use the data if our x and y variable are given. And this one is 2, this one is 5, this one is 4, this one is 6, this one is 6, this one is 8. So as we noticed earlier, as the first one is increasing, as we noticed earlier, as we noticed earlier, as this one is increasing, the other one is what? Is increasing. That shows, that's why we have the positive answer for the previous one. So for this one to calculate it, firstly we have to know our value of b. And the formula for what? For b is equal to summation of what? Of x minus x bar, then y minus y bar, all divided by sigma x minus x bar square. So this is the formula, and the formula can be what? Can be later be what? Transformed into this. For easier way, we can, it can be summation of xy minus summation of x dot summation of y, all divided by n, then divided by summation of what? Of s square minus summation of, open the bracket, x square, all divided by what? By n. So this is the formula for what? For b. So as you can see, the difference is this one has a square root and this one has a y for the correlation, and for the regression we only have summation of what? X minus s square. So we can see that's the difference between them. So for us to solve this value, we have to get the value for our b, and this is the formula for b. B is equal to what? Summation of xy minus summation of what? X dot summation of y, all divided by n, then this one divided by n, all divided by summation of s square minus summation of what? S square divided by what? N. But this s square is inside the brackets. So for us to solve it, let's continue here. So as we drew the table before, we have to draw it for this one also, in which we having our x, we having our y, we be having our x, y, we be having our s square, we be having, I think that we not have s square, yes, that's all. I think that's all, that's all. Then we be having, yes, that's all. That's all. So then we have x mean, our mean, and our y mean. So for our value here, we get 2, 5, 4, 6, then 6 and 8. So our x is going to be 2 times 5, give us 10. 4 times 6, give us 28. Is, I think it's 24. It's 24. Then 6 times 8 is what? 48. 6 times 8, right? 48. So for our s square, 2 times 2 will give us 4. Then 4 times 4 will give us 16. Then 6 times 6 will give us 36, right? Then our x mean is going to be 4. Because 2 plus 4 will give us 6. 6 plus 6 will give us 12. 12 divided by 3 will give us 4. So for this one, 5 plus 6 will give us 11. 11 plus 8 will give us what? 11 plus 8 will give us 19. Then 19 divided by 3 is what? 19 divided by 3. 19 divided by 3, 6.3. Let me just say 6.3. So these are our value that we are going to use. And as we already seen our formula here, so let me write the formula. As we have seen the formula, let's now solve it. Let me write the formula down here. Our formula is what? B is equal to summation of x, y minus summation of x dot summation of y, all divided by n, divided by n, then this one all divided by summation of x square minus summation of. So our b is equal to a summation of xy minus summation of x dot summation of y divided by n, or divided by summation of x square minus summation of what of x square divided by n. So for our to solve it, our b is going to be what summation of x y. So we haven't do the summation yet, sef. So we have the summation of x is equal to what? 4 plus 6 give us 12. Summation of y is going to give us 19. Summation of this to give us 34. 34 plus 48 give us 70. It give us 86. Yes, summation of x y is equal to 86. 82. 34 plus 48 is 82. Okay. Then this one, summation of x square, then we'll be having 36 plus 16 give us 46, give us 52, 56. Then like that. So summation of xy is going to give us 82. Then 82 minus summation of x 12 dot summation of y 19, all divided by our n is the total number of population, which is 3. Then divided by summation of x square is what? 56 minus summation of what? Of x 12 square, all divided by what? By 3. That's good. So our b is going to be, is clever, is 82 dot, what is 12 times 9? 12 times 9 divided by 3, 36, then minus 36, all divided by 56, minus 12 times 12 is what? 144 divided by 3, 48. Good. So, continuation, as we have our b is now going to be 82 minus 36 is what? 82 minus 36. 82 minus 36, 56, 46. So all divided by 56 minus 48. It gives us what? 8, right? Then our b is going to be 46 divided by 8 is what? 46 divided by 8. 46 divided by 8. 5.75. So this is our value for what? For the slope. So after we have gotten our b, we now go back to the equation. We are now go back to the equation in which it says that our y is equal to what? A plus bx. So now to get our value for a, which is the what? The line that crosses the y-axis, we are going to change the formula is going to be y mean is equal to a plus bx mean. So if it's like that, we are going to our a, to make our a as the what? Subject of the formula is going to be a is equal to y minus bx bar. So this is our formula for this one. So then we have already know that our a, our a is equal to y minus y bar minus bx bar. So then our a is going to be, what's our y bar? Our mean is 6.3. So 6.3 minus b is what? 5.75. 5.75 multiplied by, what's our x mean? Our x mean is 12. So multiply by 12. So our a is going to be 6.3 minus 5.75 multiplied by 12. 5.75 multiplied by 12 is what? 5.75 multiplied by 12. 69. Then then 6.3 minus 69 is what? Our a is going to be what? Minus 62 point what? Point 7. As you can see, we get a what? A negative number here. So that's all for this one. So after we have gotten our a, now the equation is going to be back to y is equal to a plus what? Plus bx. If our y is equal to a plus bx, our y is now going to be a is what is minus 62.7, then plus what is our b? 5.75, 5.75, then multiply by our x. We are going to leave x there. So our y is going to be minus 62.7 plus 5.75x. So this is the equation for what? For linear regression analysis, regression models. So we can see the difference here. Here we get an equations that defines the what the relationship between two variables. You see, this is the equation. But for the correlation, we are going to get a value that will stand between minus one and what plus one. So don't forget to like, comment, share, and subscribe to this channel. Thank you.